Hi, this is Mr. West, and today we're doing a Khan Academy tutorial on testing solutions to inequalities basic. This is pretty simple, so we're going to kind of roll right through it. The first thing that you are going to need is probably a number line. So if you have one, that's great. Otherwise, you can make your own. Always include 0 and then just include a few numbers on either side of 0. So I'm going to go all the way to 10 here, 9, 10, and then I'm going to go into the negatives as well. So there's negative 5, 6, 7, 8, 9, and then negative 10. Okay, so I'm going to go ahead and start then. I'm asked to select the values of x that make the inequality true, and there's my inequality. We got to be able to first read this inequality, and this says x is less than 2.1. Now, when it says less than 2.1, it cannot include 2.1. So if we're listing a bunch of numbers that are included with this, 2.1 is what I like to say, not invited to the party. So if I'm going to do this using a number line, the first thing I'm going to do is roughly locate where it is. So 2.1, the number that's listed here, is roughly there. Okay, and it's not too important exactly where it is. Now, if we're talking about the values less than that, we are talking about all the values to the left. So this is actually how you graph inequalities. But I just wanted to give this as a visual representation of the numbers that can be included. So what we're going to do here is we're just going to go through each one of these numbers, and decide, is it included in this blue solution area? So negative 2. So if we're trying to find negative 2 here, negative 2 is right, let me use green actually. Negative 2 is right about here. And as you can see, negative 2 is in fact less than 2.1. When you're seeing less than on a number line, less is to the left, and then greater is to the right. So you can see the R right, L less to the left. Okay, I hope that helps a little bit. But anyway, negative 2 is to the left of 2.1. So therefore, we're going to select negative 2 as one of our choices. 4.3, so locate 4.3, that's over here. That is to the right. It is greater than that. It's not in our blue solution area, so we're not going to select 4.3. That one's out. Negative 0.7. Well, if you notice here, anything in the negatives for this particular graph is going to be in the solution set. So negative 0.7 is to the left. 1.8 is to the left. As we can locate, I'm just going to, for being thorough, there's negative 0.7. 1.8 is close to 2, but it's still to the left. And then 3.4 is bigger than that. Those are the ones that are out. These ones are A-OK. So we're going to go with that. Check our answer. Next question. So again, we can make a number line for this. Okay, just like for all of these. In this case, I'm just going to list 0, and then I'm going to list 27. And that's really the only two I need. I could list a few other ones like 30, and maybe put some negatives if I really wanted to, like negative 5. But let's interpret this. So this is 27 is less than x. Oftentimes you want to see, it's better to have the variable written first. So if you don't have the variable written first, I would like to encourage you to write it first until you're comfortable understanding inequalities. A lot of students get tripped up by this with the variable on the right. This just means the values greater than 27. So if we locate 27, 27 is not invited. And the reason why we know that is because it's a less than sign, not a less than or equal to. If it's less than or equal to, it could be equal to 27, but it has to be greater than that. So we look here, x is greater than 27. We're talking about all these values to the right. And again, you don't need to graph this. I just wanted to show you which ones can be solutions visually also. So 21 is clearly to the left. 21 is over in this area. So this one's out. 25 is also out. That's to the left. We're looking at values that are greater. And again, greater is to the right of 27. So that one's out. And 30 is the only one that is included. Okay, so that one's good. These ones are not. So 30 is the only one that applies here of values that are greater than x. Okay, again, I would encourage you to first write it as x is less than 9. Make sure if it's eating the number, make sure it stays eating the number. Don't flip it and then also do that. That's changing the inequality. That's bad. Don't do that. Okay, I'm going to erase it so you don't even see that stuff. So we're looking at the values that are less than 9. If you don't want to use a number line, you don't have to. You just have to select the numbers that are less than 9. Don't choose equal to. That one's not correct because it's not a less than or equal to. So those are the two values that are less than 9, and that's it. Okay, now this one is a compound inequality. So that's why it wants it to have solutions to both. So we need something that is both x. Again, I like to do it where x is on the left. X is less than 128. It's e to the number, so it needs to stay e to the number. And then x is greater than 82. Okay, so this one may be useful to have a number line for. So I'm going to go ahead and draw that, and I'm going to draw 82. I'm going to draw 128. And I know that it has to be less than 128, so I'm going to start here at 128. It's not included, and I'm going to go this way. But I also know that it has to be greater than 82, so I'm going to circle 82, can't be included, and I'm going to the right. And you'll see as these two approach each other, they're going to meet in the middle, but I can't keep going this way, okay? Because it says x is less than 128, I would want to keep going to the left, but I have to stop at this one because both conditions need to apply. Okay, and if you're confused on this, I believe I have videos on compound inequalities that you could look up. But otherwise, this is pretty thorough just for this simple exercise. We're looking for something in between 82 and 128. Has to be bigger than 82, but less than 128. Okay, so if I'm looking at this, I'm looking at all three numbers, and I'm seeing that all three are in between these two numbers. 83 is here, 118 is here, 127 is right there. All three satisfy these two inequalities in combination, and that's it. Hope you enjoyed this video. If you have any questions, be sure to leave a comment in the space below, and I look forward to seeing you next time right here on Wes Explains Best.